A large portion of my IT history is not really in server administration. It's more so in desktop administration. CPT Nuggets has had me put together the MCSE desktop credential, the two videos in that series. And if you haven't had an opportunity to see the really popular configuration manager series we have here on this site, there's all kinds of content there that'll automate your desktop administration in a lot of ways. I bring this up not just as a commercial for some of the other series that I've put together, but also because desktop administration, some of the things that you do in desktop administration come to mind when I start thinking about the differences between vSphere standard and vSphere distributed switches. I think I said it last in that last nugget that a vSphere distributed switch is kind of almost like a group policy for vSphere networking. Without a distributed switch, if I have three hosts, like I do here in this environment, I'm going to have to go through the configuration of the networking on each of those hosts individually. And as you saw back on that last nugget, there's a whole lot of different settings that have to get configured for things to be done correctly. And a whole lot of settings with a whole lot of machines usually crosses together to equal the potential for a whole lot of mistakes. A distributed switch, more so than anything, when you have the Enterprise Plus version of vSphere, a distributed switch, more so than anything, allows you to sort of manage the switches across all your hosts from a single location from a policy based approach. So, kind of like group policy, kind of like how you use group policy to manage the individual configurations on desktops. Well, putting this into place requires there to be a bit of logic, a bit of intelligence that sits at the server side in addition to each of the individual ESXi hosts. So one of the things you'll find is that even though the switches themselves still sit on the individual hosts, we actually have to create some constructs that exist not on the ESXi host, but in fact in the vCenter layer itself. Here's my vCenter server. A distributed switch is an object, is a concept that exists only at vCenter. It's there in order to provide the central location where all these policy-based configurations get kept and then ultimately passed down to each individual ESXi host. The neat thing is that when you go about creating a distributed switch, you can very easily import in new hosts and have them almost automatically get the settings that are appropriate based off of the policies that you've set. In addition to just the ability to manage things from a centralized policy sort of approach, distributed switches also support some more advanced sort of data center enterprise type functions that you would probably want, especially as the size of your environment gets larger. Distributed switches support NetFlow, support port mirroring. If you have the need for private VLANs, which are kind of growing common in DMZ environments, well, you're going to need a vNetwork or a vSphere distributed switch. Distributed switches also include a new load balancing policy called route based on physical NIC load, which, similar to the other policies like IP hash and MAC addresses, this one provides the ability to load balance your traffic not on based on who you are, but based on what you're doing. And again, only available here in those distributed switches. So as I said before, your use case for these really is, have you bought Enterprise Plus? And if you have, well, there's probably it's probably a good reason to go ahead and implement them. Because although you're going to see a whole lot of settings, as we step through those settings, you'll find that they're not really too bad if you go through things in a very careful manner. To that end, in this nugget, we are again going to focus in on some of the simplistic implementations of vSphere distributed switches. We're going to create one that, as I said before, is going to exist here at the vCenter layer. And once we create that one switch, we'll use that switch or connect up that switch to the individual ESXi hosts that we have. So we're going to create one switch, we're going to plug in all the individual standard switches so that we can manage them from this single location. We will migrate not only our physical adapters, but also some virtual adapters to a vSphere distributed switch. Back in that last nugget, you heard me referring to VM kernel ports. Well, in the distributed world, a VM kernel port and a virtual adapter are essentially kind of the same thing. So you've got a little bit of extra terminology that you'll have to think of here as we go through this nugget. We're also going to configure what are called DV port groups and DV uplink groups. The DV port groups you can think of as the things on the left side of the switch, and the uplink groups on the right side of the switch. We call them this not so much because, as before, on the right side of the switch were all the physical things. Here are the logical references to the actual physical addresses or physical NICs. This will make a lot more sense when you kind of see the nice graphical visualization that comes up next. We're going to configure those virtual adapters. We're also going to take a quick look at LACP on uplink port groups. I don't want to spend too much time because you can get really complex with LACP, especially if you start taking LACP into its ultimate conclusion, which is spreading your traffic across multiple switch infrastructures if you want to. We can do some monitoring of DV port state, which is a neat little tool that lets you see the traffic coming in and out of each individual port. And one quick look at the backup and restoration of your vSphere distributed switch. There's one link to export it. There's one link to restore it. So let's take a look now at what we need to build here in our vSphere environment to get these distributed switches up and running. I'm going to log on here to the vSphere web client. And before we get too far into the distributed switches, let's take just a minute just to review what we did with the standard switches back during that immediately previous nugget. I'm going to come here to vCenter and take a look at hosts and clusters. And that server ESX1 that we spent all the time with back on that last nugget, we built a virtual switch. In fact, we built two of them. The first virtual switch, vSwitch 0, has two networks on it, a DMZ network with VLAN ID 11 and a VM network with VLAN ID 10. So the parallel to your data center is, you got a server net and you probably got a DMZ net, and you'll have some virtual machines on the server net and some on the DMZ net. The way in which you logically separate those is by associating them to a VLAN ID. For this switch, in order to support high availability, we've got two physical adapters. These are connected up right now, not using Ether channel. We're just using that non-network assisted load balancing that we can make available by choosing which of the load balancing policies that we had. Over here on vSwitch 1, we only have a single NIC. Probably not a great configuration because that single NIC means that if the NIC goes down, we're not going to be able to do vMotion, and we're going to have complete loss of management connectivity. So this is a great starting point for this configuration, but let's take this server ESX1 and pull all the information that we've already created to this point up into the distributed switch. Once there, we can make some more intelligent decisions about how we end up distributing out this traffic. So in order to do that, let's, instead of being here in hosts and clusters, let's take a look instead at the networking node. Now, one thing that's interesting about this networking node, and it's something that could be easily confusing for you if you're using standard switches, is the recognition that these two little networks that we've already created before, the VM network and the DMZ network, are represented here in the network view, even though they're only on one of the three systems that are currently a part of this data center. And so I bring this up just again. There are ways in which standard switches can kind of be a little confusing as you're trying to manage them over time and over a large number of ESXi hosts. What we want to do here in this data center is to actually go about creating a new distributed switch. So I'm going to just create one. We're just going to call it D-switch here. I'm going to choose next, and then I can identify which version of the switch that I want to create. Now, in a perfect world, you'll create that switch as a version 5.5 switch because it includes all the new functionality. But if you have older versions of the ESX operating system, and hopefully you won't spend too much time in that hybrid state. If you do, well, then you're going to have to use one of the older versions of the D switch. Okay, so we're going to use a 5.5 version, but there is a way that you can migrate and upgrade your D switches once you get yourself up to the newest version. I'll choose next, and from here we can edit the settings. This edit settings screen can be just a little bit confusing because VMware is sort of notorious for not giving you really good descriptors for what a lot of these configurations are for, and so you got to kind of figure out what some of these things do. A lot of the confusion can happen here with the number of uplinks. Now, what this says is that this is the maximum number of potential uplinks that each connected ESXi host can contribute to this distributed switch. Okay, so you think of this as kind of a maximum level. You can have ESXi hosts that only contribute 2 of the 4, for example. So this will be the maximum number of uplinks that any host could contribute once they get rolled into this distributed switch. Down here we have network I/O control currently set to enabled. I told you there were some great new features you get with D-switches. One of them is the ability to do some I/O control for your networking. A little later on when we start talking about resources and how we can manage and balance resources, network I/O control will make a lot more sense. So for now, let's just leave this enabled. And at this point, I don't want to create a default port group. I want to create some specific port groups a little later after we start importing in our hosts. So with that, I click next and finish, and wow, bam, there we go. We've got ourselves our very first distributed switch. Congratulations, you are now a distributed switch enabled data center. Let's take a look at the switch itself. Okay, so here's dswitch. And as I said before, VMware does a great job with these switch settings. If I come over here to settings, I get a really nice, just easy to visualize topology view of the configuration that we put together here to this point. Now you'll notice, well, gosh, Greg, there's just not that much here at this point. I see the switch, the gray box, and then on the right side I see 4 uplinks, but the uplinks apparently have no NIC adapters. Remember, what we are creating at this point is an empty container at the vCenter layer. We've created the container in such a way that we can then import in our ESXi hosts and the associated NICs, the adapters on those hosts, to populate the things over here on the right-hand side. We'll start doing that population here in just a minute, but before we do, let's create some of the structures, some of the port groups here over on the left side that we'll need as the target locations for the ones that we've already created down in our standard switch. Now, we've kind of created these already, right? When we created that standard switch, we kind of did some of this work ahead of time. So we had, 4 port groups here, and we've kind of looked at these already. We had one port group that was the server net. We had one port group, and I think that was VLAN 10. We had another port group that was the DMZ net, and that was VLAN 11. And then we had these 2 VM kernel ports here. One was for management, and then one was for vMotion here. Now, as you can see, these are kind of similar to what we were looking at before, although in the standard switch world, we had them broken up into different switches. Here, we're going to keep them on the same switch because, well, I want this switch here to manage all of these configurations across all of the hosts. So I'm going to keep my traffic separated out, segregated out, and then plug it into my DV switch. And then over on this side, plug that DV switch into the links to the adapters on each individual host, and ultimately all the way back out to the rest of the cloud. A lot of linkages going on here, and we have to keep these straight in our minds if we're going to be successful with the import of that first host. So let's go ahead and create a couple of port groups here. First port group we want to create is going to be that server net port. So this is server net. And we'll choose next here. We're going to choose port binding as a static binding here. So we're not going to worry about any kind of dynamic binding. We're not going to worry about ephemeral binding, any of the kind of advanced topics here because we want to keep things simple. And I'm going to keep the port allocation actually at elastic so I don't have to specifically identify a number of ports. I mentioned back in that last nugget that this new elastic feature is nice because I want vSphere to manage what the maximum number of ports should be based off of how many I'm actually using at the time. We're not going to worry about network resource pools here yet because that's a topic for coming up. And this is our server net, so this will be a VLAN, the type of VLAN here. That VLAN ID will be VLAN 10. Now the assertion here is that we're going to be pulling in a trunk port that says, all right, this is VLAN 10 coming in. Go ahead and distribute that out to any of the machines that are associated with this port group that we create. I can configure policies if I want, some of the policies you've seen before like traffic shaping and teaming and failover. For now, let's go ahead and just leave that unchecked because again, we're working real simple here. Choose finish and there we go. There's our first port group. I need to repeat this process now for the DMZ port group. So we'll call this DMZ net and choose next. We're going to do static binding again. We're going to do VLAN here for VLAN 11 and then next and then finish. Have to do it a third time now for the third and a fourth time for the 2 VM kernel ports that we had. The third one was management. So this is our management location. The management location should keep everything the same here, except we're going to choose a VLAN type of none because this is going to be an access port. Right? We're going to have an IP address that's directly tagged to this. Choose next again and finish. And then lastly, we'll create one more here for our vMotion network. This one will be vMotion. Curiously, VMware actually changed how the spelling for vMotion worked. I don't know if you know this over the years. I think vMotion actually had a capital V for a period of time, and lately now it's a lowercase v and a capital M. I don't know, the marketing team, I guess, got a hold of it and needed to make it all pretty. So with the vMotion port group here, again, we're going to have IP addresses associated with those vMotion ports, and so the VLAN type here will also be none. Choose finish, and we're done. So a lot of work here, but remember, we're doing this in one location. And once we do this in one location, well, then it's going to propagate out to all those hosts as we begin importing in the hosts. Let's begin with ESX1. Let's go ahead and import in that host, ESX1. I'll choose add hosts here, and the host I'm interested in adding is that server ESX1. There we go. Choose OK. And then what we want to do first is figure out exactly what bits of the existing configuration of ESX1 that we want to pull in to this new distributed switch. Well, we definitely want to do its physical adapters, right? We want to manage its physical adapters. And those VM kernel adapters, the management net and the vMotion net, I want to manage those too. They're over here. And I probably want to migrate the virtual machine networking as well, right? I've already got my ports created for that, or my port groups created for that. But you know what? Let's just leave the advanced host settings there. Let's leave that the same. So I'll click Next. And then that brings us to managing the physical network adapters. Now, if you recall, when we created the standard switch, we associated some of the NICs, specifically VM NIC 0, 1, and 2, to the V switches that we created, the standard switches that we created there on those hosts, on that host ESXi. So they're currently in use by, well, vSwitch 0 and vSwitch 1. What I need to do is then assign those uplinks to one of the 4 uplinks that we created for this D switch. Okay, if you recall over on the right-hand side, there were those 4 different empty uplinks. Well, all I'm going to do is say, you know what, VM NIC, you know what, let's just not do VM NIC 0, just to make things easy. Let's do VM NIC 1 to uplink 1. Let's do VM NIC 2 to uplink 2. Let's do 3 to 3, and then 4 to 4. Just makes sense, you know, we'll keep the naming kind of the same. Now, doing this allows me to have a single NIC that still exists down there on a standard switch. That will ensure that perhaps if my DV switch ends up having kind of a problem, well, I will still have the ability to manage that host because that V switch and its management connection still exists over there. So thinking ahead here. Choose Next. And now I need to manage my VM kernel network adapters. So those VM kernel ports we were talking about before, they're now called virtual adapters. The 2 ports I'm interested in are VMK0 and VMK1, which you'll probably recognize as being the management group and the vMotion group. Let's get those reassociated now to the port groups that we just created. So there's the management port group. Choose OK there, and for the vMotion port group, let's send that over to the vMotion port group. Awesome. So now I got those 2 VM kernel network adapters correctly configured to support, or to continue to be supported as we start working with them here with this distributed switch. I'll choose Next. And take a look at the impact. Looks like, nope, we're not going to end up having any impact here by making this change. And that takes us here to the final screen for migrating VM networking. Now, one of the things you'll notice here is that this screen is actually empty. And it's empty because, well, we don't have any virtual machines yet. So there's really not anything that we have to do at this point for migrating that VM networking, but we are bringing it under management here on this distributed switch. If I choose Next and then Finish, you'll notice that now we have some connections that have occurred here between the DV uplinks on one side, and on the other side we have the networks that we've created, that we've associated with that host ESX1. Let's see what we have here. All right, so we have one NIC adapter here, so that's ESX1. Here's my VLAN ID. There's my VM kernel port. Yep, it is now under management there. The port is under management here, although we're going to have to ensure that that gets changed for the DHCP address that it probably currently has. But really, all of these are looking pretty good here for this distributed switch. The next step in the process is just to repeat this entire process by adding in another host. So we add in another host. In this case, that host will be ESXi2. Now, the second time around and the third time around, a lot of this stuff gets a lot easier because we've already gone through the process, right? So I'm going to take NIC 1 and assign it to uplink 1, and 2 and 2, and 3 and 3, and so on and so forth. But the neat part here is, again, the fact that in the process of doing this, everything becomes part of the policies that we set on this distributed switch. Choose Next here. I need to, well, in this case, I need to associate and then create a VM kernel network adapter. And here's one for vSwitch 0. Let me go ahead and assign that up to the management port group here. And then I need to create a new adapter over here on the other machine. So create a new adapter, associate it to the distributed port group for vMotion. There we go. Choose Next. and then give this the appropriate settings. The services for vMotion right down here. We're going to keep that same label, vMotion there, and then the IPv4 settings, which in our case, we'll just like before, we'll do that automatically via DHCP. Click Next and Finish, and there we go. There is our new VMK0, VMK1 to go on our management and vMotion port groups here on our distributed switch. Choose Next. No impact, don't have to worry about VM networking because we don't have any VMs, and Finish. And now we have our second machine that we've pulled in to this distributed switch. You should at this point start to realize kind of why the Enterprise Plus version costs so much, because as you start looking around at the functionality that you get here with these distributed switches, and even some of the other awesome things that you'll get out of Enterprise Plus, this can come in really handy. You think about all these different configurations here. Well, I'm now just routing them through the individual network adapters on each host. So I know that, well, all right, so if I need, for example, this port is going to run through these 4 adapters and be appropriately load balanced because of the way those load balancing configurations have been set up. So very policy based, very easy to kind of manage things once I get these things pulled in. I'm not going to show you for the third server because that would be just a repeat of everything we've seen up until this point. But there are a couple of additional topics that we do want to talk about here in this nugget. One is really cool. One is the way in which you can monitor your DV port states. So to turn on monitoring and just watch the metrics go by as the network traverses through the switch. We can take a look at that here actually by looking at the ports node. If we go over here to ports, now you're not going to see much at this point because we don't have any virtual machines really to take a look at, but you can see how our switch is dynamically adjusting the number of ports it needs based off of the number of, well, connections that are necessary. There's my management connection, there's my vMotion connections, there's my uplink connections. And if I scroll over here to the right, well, I can see what the state is, and then even potentially some statistics. So my broadcast, my multicast, both on ingress and egress, how many drops, frames, what the exceptions were, what the egress packets were, how many were accepted. So it's just nice stuff that we have here once we start pulling stuff and consolidating it through that logical switch. If I need to troubleshoot one of these ports, you know what, I got a problem with, I don't know, I've got a problem with the management port today here for one of my hosts. I can click on this and then run this little button up here that says, you know what, let's start monitoring that port state. That monitoring will occur and start to populate these statistics with useful information that'll help me understand if I've got some sort of performance issue or some sort of maybe a problem with drop packets or a noisy network card, although I'm not sure how often that happens in the logical world, but any of the issues that we commonly associate with having a network issue. When I get done with that, just turn it off and it's done. So monitoring these states, just a nice way for you to be able to just kind of see what sorts of things are going on inside this environment. Now, a couple of the other nice bennies that you get out of a distributed switch are a couple of load balancing policies that you wouldn't normally see inside of a standard switch. Let's actually take a look at some of those load balancing policies here, so at least you're aware of where they're at. I'm going to take a look at, let's say, our server net here. Now, when we originally created this server net, we set it up via and I forgot the routing policy we set, route based on originating port ID. Let's take a look here at our teaming and failure. Route based on originating virtual port. So in the route based on originating virtual port, I have the situation where I don't have to have any modifications to my physical switch infrastructure. I don't have to have my engineers turn on Ether channel, but I don't really have great load balancing. I have more like failover than real true load balancing. I can get load balancing if I switch things over here to the route based on IP hash and then have the network team turn on Ether channel. So that's one option. Well, I also have the option here in the distributed switch. If I don't want to go down that route of interfacing with the network team, I can do route based on physical NIC load, which adds a little bit of intelligence to some of the other non-switch facilitated load balancing features, so that every so often as we take a look, or as your vSphere environment takes a look at the switch load, it can move how it's routing these different connections around inside of this distributed switch in order to sort of balance the load out. So that's one new feature that you get, again, whenever you make the move here into the distributed switch. And if you don't want to go down to switch enabled or switch facilitated load balancing, this is one that you can use. If, however, you do have some of the more data center centric or advanced solutions in your environment, if you do have some great Cisco gear that you really want to work with, well, the perhaps better approach is to use 802.3 AD, is to use LACP. Now, LACP is a mechanism for you to be able to do some really slick load balancing across all of these different hosts, but it takes a little bit of configuration to set up. Let me switch back here, back to the D switch again. You'll notice that LACP is now a setting here on the switch properties. So let's take a look at the LACP item here. Now, LACP gives you some really, if you have the hardware that supports it, gives you some really fine-grained control over how you end up routing all of this traffic around your logical and ultimately your physical network. One of the big things that has been a limiting factor at this point with a lot of the load balancing configurations we've set up is that here in our environment, let's say this is our vCenter environment, and then these are our ESX machines down here. Well, at some point, I've got to plug all this stuff into a switching infrastructure. And a lot of these configurations require me to plug these multiple connections from my ESXi host into a single switch. Well, that's great, except for the fact that this switch becomes a single point of failure. If I lose the switch, the entire thing falls to its knees. Well, one of the things that LACP does a really good job of, if you're willing to go through the effort to set it up, is to configure multiple switch load balancing. So with this multiple switch load balancing, we are, again, if I can kind of draw my little diagram here, we are essentially setting up the ability for us to create or remove that single point of failure in the infrastructure. So now I have hosts that are connecting up their variety of network connections, not just to one switch, but to multiple switches. One of the ways in which you accomplish that is by creating these lags here, these LACP, what are they called? LACP aggregation groups or link aggregation groups. And I'm not going to go too detailed into the process of creating these link aggregation groups, but what you need to know is that you're essentially going to create one or more link aggregation groups. You're going to set what the load balancing mode will be for those link aggregation groups, and you'll see there are a variety of different ways in which you can set those, although the default here is a common one. How many ports you want to have, and then once you've configured them, you need to apply the policy to one or more uplink port groups. When you apply them to the uplink port groups, well, then that will enable LACP. And if your network infrastructure is ready, we'll then begin to pass that traffic out through the physical infrastructure. I'm not getting too detailed here because as we start getting into high availability on top of high availability on top of high availability, it begins to become more of a design task that's better suited for perhaps another series. So be aware we have LACP functionality here, and if you need to get your equipment split up across multiple different sets of routers to eliminate that single point of failure, well, you can do so here. We have one more topic we want to talk about in this nugget, and that's just simply the fact that there's a whole lot of settings here, and wouldn't it be great if I had some way of copying this or backing up or exporting this configuration just in case something might happen at some point down the road. Well, thankfully here under all vCenter actions, we have the ability to export that configuration, the switch and all the port groups, out to some location that we can ultimately restore. Once it's been exported, then we can later import in the configuration by going back here and choose to restore the configuration. So if I have the file, I'm going to be able to put all these settings back in their proper location. So still more to talk about these distributed switches, but what have we talked about in this nugget? We've talked about the introduction to distributed switches. These distributed switches are a great solution as the number of ESXi hosts starts getting high. You just having to manage those things with a lot of hosts, a lot of configurations, it's just going to get unwieldy over time. You do, again, have to have the Enterprise Plus version of the operating system in order to support this. If you don't, well, then you might just want to move on or consider upgrading. And then down in the interaction portion, we created a vSphere distributed switch. We added some hosts. We migrated over those virtual adapters, the physical adapters, and then we configured our DV port groups and our virtual adapters, took a look at LACP, showed how we could do some nifty monitoring, and talked about the backup and restore of our VDS configuration. So yes, this is just the basics. This is just kind of setting up things so that in our next nugget coming up, we can talk more about the standard and distributed switch policies. We've kind of flitted around with these policies already because I needed to just to get some of these constructs up and running. But in that next nugget, we're going to spend more time talking about the policies and where you might implement them, and in some cases, why you might want to turn them on in your infrastructure at home. That's the topic for our next nugget, so until then, I hope this has been informative for you, and I'd like to thank you for viewing.